Good morning. Myself, Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is MOS IV characteristics from the unit 1, which is a MOS transistor principle of the subject name is VLSI design. Let us discuss. These all are the topics to be covered in this lecture video. Introduction to MOS IV characteristics. The MOS IV characteristics describe the current voltage relationship of MOS transistor, fundamental components in modern integrated circuits. These characteristics provide insight into transistor behavior under varying operating conditions, crucial for circuit diagram analysis and optimization. And an on transistor passes a finite amount of current. Transistor, gate source, drain all have capacitance. Capacitance and current determine speed. Okay. Next one is MOS capacitance. A MOS capacitor consists of metal gate separated from a semiconductor substrate by an insulating layer. It forms the basic structure of MOS transistor used in integrated circuit. And operating modes, there are three types: accumulation, depletion, inversion. Okay. We will discuss briefly. Accumulation occurs when a sufficient positive gate voltage is applied to one MOS structure relative to substrate. And depletion occurs when a small positive voltage, the positive gate voltage, is applied just above zero to an MOS structure relative to substrate, that is body. And inversion occurs when a sufficiently large positive gate voltage is applied to one MOS transistor to the substrate. Okay, we will already we know the operating regions. What is operating regions? What is mean by operating point? I will give operating region introduction. There are three types of region, that is cutoff region, linear region, saturation region. When the gate source voltage is below the threshold voltage, the transistor is non-conductive and no current flow between drain and source terminal, which is called the cutoff region. Next, linear region, as VGS exceed thermal voltage and the drain source voltage, that is small, and the transistor operates as a variable transistor, is drain current and linearly proportional to the VDS. Saturation region, the VGS sufficiently higher than the VTH and the VDS, the transistor enters saturation where IDS become relatively independent of VDS and primarily depends on VGS. And operating modes. Understanding these three, accumulation, depletion, inversion operating mode, is crucial for designing and analyzing of MOS transistor in integrated circuit. They illustrate how the conductivity of channel, you can see the diagram, illustrate how the conductivity of the channel can be manipulated by controlling the gate voltage relative to substrate and influencing the transistor functionality and performance in various electronic applications. And mode of operation depends on the thermal voltages, that is VG, VD, VS. We will discuss the thermal voltage. control the conductivity between source and drain terminal, which is the gate. Source means the terminal through the terminal through which current enters or exit the transistor, that is called source. And drain is the terminal through which current exit and enter the transistor depending on the type of transistor, which is called like NMOS or PMOS. NMOS transistor or PMOS transistor. Yeah, you can, that is gate voltage, drain voltage, source voltage. VGS is nothing but the, which is equal to the VG minus VS. VG, you know the what is VG? Gate voltage. VS is thermal, which means source voltage. VD is drain voltage, and VGT is nothing but the VG minus VD. VDS is nothing but the VT minus VS. Source and drain are symmetric diffusion terminal. And already we discussed the different types of transistor region, that is cutoff region, linear region, and saturation region. Okay. Yeah, NMOS cutoff, no here, no channel, IDS, which means drain source current equal 0. Condition is gate source voltage less than thermal voltage, that is VGS less than VS. No current flow from drain to source. And next one is NMOS linear, that is called triode. Condition is VGS gate source voltage greater than thermal voltage VTS, and VDS lesser than VGS minus VTH. Current flow from drain to source is controlled by the VDS. Yeah, VDS. Okay. Similar to linear resistor. And NMOS saturation. Current is relatively independent to VDS, primarily controlled by VGS. This is called NMOS transistor. Condition is VGS greater than V thermal, and VDS greater than or equal to VGS minus V thermal. And current voltage characteristics, graphical plot of IDS versus VDS for various VGS, which means gate source voltage, carrier velocity and activity, speed at which charge carrier move through the semiconductor material under the influence of an electric field. Activity, which means refers to the state of the transistor based on the applied voltage. Yeah. Okay. NMOS, PMOS current voltage plot. NMOS shows how IDS varies with VDS for different VGS, and PMOS IV plot so how characteristics of with opposite polarity due to different doping types. And channel charge mass structure look like parallel plate capacitor while operating in inversion. Gate oxide channel. Here equation, you can see the equation. And yeah, carrier velocity and activity. Carrier velocity. mobility. V equal to me. V is nothing but the carrier velocity v proportional to the lateral e field, capital E field, between source and drain. V equal to me. M is nothing but the mobility. The NMOS linear, this is already discussed. Example. Okay. Okay, these are the assessment of this lecture video. Note it down. If you have any doubt, you can ask me through the comment. Yeah, we will meet in next video. Okay, thank you.